So these pigs, when they have blood running out of their nose, oftentimes they'll have kind of purple bellies, the purple skin of their bellies and ears. Yeah. That's the result of this endotoxic shock that actually killed them. It's an incredibly virulent organism.
Hello, welcome to this edition of Meet the Expert, a new series of podcasts on swine disease management in practice presented by Boehringer Ingelheim. My name is Peter Best. Dr. Stevenson, we're talking about APP here, and for this Meet the Expert podcast, APP then is not a primary cause of coughing in the barn. It's not the first thing you think about when you hear coughing, is it?
No, not at all. And actually, APP, there are many serotypes of APP, more than 15. And in each region of the world, there typically are 1, 2, or 3 serotypes that tend to have the most highly virulent strains in them. And when we talk about APP, what strikes the fear in the heart of swine producers are the highly virulent strains. So I just want to be clear that we actually have kind of a whole gradient of diseases associated with APP, but the one we talk about the most are the highly virulent ones that are characterized by finding, classically, you go out and you think everything's going well, and then you go out and you find a really big, nice hog dead with blood running out of its nose. And a lot of times you didn't see it sick. You may have checked them in the morning. They all look fine. You come in the afternoon and you got a dead pig laying there with blood running out of its nose.
So you do necropsy on that dead pig. What do you find?
Well, you have a lung that has the consistency of about a firm rubber ball. It's really firm, but it's still resilient, and it's non-collapsing, and it's covered with fibrin, and it's got hemorrhages all over it. And there'll be foamy, bloody foam filling the airways all the way up and running out the nose of the animal. So in pathology terms, we'd call that a fibrinonecrotic pleuropneumonia. There's fibrin covering the pleura, and if you cut across that lung and to look at it on end, it'll have irregular areas of hemorrhage and necrosis. And you can tell it's necrosis because the tissue has kind of a dry look. It's not shiny like viable tissue. And if you rake the end of it with a knife, it'll kind of flake off like feta cheese, if you will, blue cheese.
Wouldn't it take some time for that to develop within the pig?
You would think so. But the crazy thing is, you can inoculate perfectly normal animals with highly virulent APP, and they can be dead about 10 hours later or less.
And you didn't see anything?
You didn't see anything.
Meantime.
They will just die. It is an incredibly rapid virulent disease, and that has to do with the way it causes disease. When a pig, let's just take the simplest case. Let's say that a pig has never seen APP before, and a pen mate gets sick and rubs noses with a perfectly normal pig. So the perfectly normal pig for the first time is exposed to this highly virulent APP, and it goes in its nose, and then the animal sucks it into its lungs with an inhaled breath. When that APP gets down to an alveolus, it actually attaches to the alveolar lining cells. They're called alveolar pneumocytes. And from there, it starts multiplying. But what makes APP really unique is it's got some components, some things it does that are called virulence factors. One is it's got a really, really thick polysaccharide capsule that surrounds it, and that capsule keeps phagocytic cells, macrophages and neutrophils that would normally engulf them and kill them. They can't engulf them well because that capsule is so slick. It's called antiphagocytic.
It's got a starch jacket.
It's got a starch jacket, exactly. But the most important part of these bacterial cells is that they have a family of genes that code for protein toxins that are called leukotoxins or cytotoxins. There are 4 of these that can potentially be produced by strains of APP. They're called APX1, APX2, APX3, and APX4. What makes these so lethal is that these toxins are proteins that the bacteria secretes into the milieu around the bacteria itself. So the milieu is into the lung tissue, And they're little molecules that then diffuse away from the bacteria. When they reach a certain concentration, meaning you have lots of these bacteria producing it, it goes out and it literally just kills all the cells in its path. It lyses red blood cells, those are hemolysins, leukotoxins, lyse and kill phagocytic cells, neutrophils and macrophages, and then the cytotoxins will actually, they kill the other cells. So like the cells that produce the collagen that separates the lobules, it actually kills those cells and liquefies the collagen. So the thing about this thing that's so different is that most bacteria, if they infect one lung lobule, the only way they can affect another lung lobule is for it to be coughed up and suck down another airway.
Right.
APP just starts here and goes, it's like an invading army that nothing can stop, and it just goes going out and out and out and out. It doesn't have to go up an airway. It just goes out across everything in the lung and just kills lung. That's why it can go so fast. And then the last thing that it does that's even more fatal to these pigs is that it releases what's called endotoxin, large amounts of cell wall product that causes a systemic and vascular event in the pig called endotoxemia, and it sends the pigs into fatal shock. So these pigs, when they have blood running out of their nose, oftentimes they'll have kind of purple bellies, the purple skin of their bellies and ears.
Yeah.
That's the result of this endotoxic shock that actually killed them. It's an incredibly virulent organism.
And very rapid?
Very rapid. They will die literally in the real world. There's a pure acute form of the disease where animals, from the time they start getting sick until they're dead, it's usually within a day. Just one day. Now, some pigs can survive that, and that's called, instead of peracute, that's acute, and they'll live for 2 or 3 days before they die. And then a few pigs will survive that, and they'll end up with these areas in their lung that have been completely necrotic. And those areas will liquefy, and they'll be walled off with a big scar capsule around them. And these pigs will still be out in your finishing barns, not growing very well, by the way, because they've got these holes in their lungs.
Yes.
But those holes can rupture, and they can re-release organisms. So you'll get your barn so they all look healthy again. And then one of these animals that has these holes in their lungs, they're called sequestrum. A sequestrum will break, and you'll have a re-outbreak in your barn from that animal that's a chronic animal with the disease.
So carriers or unsuspected infected pigs are the biggest problem that you face in practice, aren't they?
Yeah, and the kind I just described, the ones that carry it in these sequester in their lungs, are just one kind of carrier. There's actually a more nefarious kind of carrier with this organism, and those are subclinical carriers. So let's go back to our first example I gave, where we have a sick animal that rubs noses with an animal that's not sick, and then that one that it rubbed noses with got sick. Not every animal you rub noses with actually gets sick. If they get a lower dose of it, instead of getting all the way down in their lung, if it doesn't get sucked down to their lung, it can end up colonizing and end up in crypts in their tonsils that are up in the upper part of their throat. And they live down in little abscesses in the tonsils, and they establish themselves there as a little colony. And the pig doesn't get sick, but it can develop a little bit of an immune response, just enough to keep the thing there, but not enough to kill it. Those animals are called subclinical carriers, and that's actually how the organism stays long-term in swine herds.
So if you necropsied this particular pig, you wouldn't see any lesions or any evidence because they're present in the tonsils, but not causing anything that's
not
detectable.
Causing any disease. So now if we have a herd that has a few of these animals in it that are carrying a highly virulent strain as subclinical carriers, but the herd is being managed well and is a minimal disease herd. Let's just say, for the sake of argument, that this herd is free of Mycoplasma pneumoniae, and they're free of PRRS virus, and they have really good buildings with really good ventilation, and the owner doesn't overstock his buildings so that they're not overcrowded. So you have a really well-managed farm. You could have a herd infected subclinically with a highly virulent APP strain that doesn't exhibit disease over long periods of time. However, if in that herd you have something happen. For example, you have an electrical outage in winter and your temperature plummets in a building and the building builds up with steam and carbon dioxide and the pigs get rather stressed during that period of time. Now, because they're chilled, their mucociliary apparatus starts working less efficiently. Their clearance of bacteria is less efficient. And if one of those carrier animals sucks a little of that APP down and it doesn't get cleared because the animal's cold, that animal could break with APP and start an outbreak in your herd.
So it's an unexploded bomb that explodes.
That's right. That's right. And that's actually kind of what happens with APP. We have these carriers, and then we have other events that happen. Mycoplasmosis, we've already talked about that. If you have mycoplasmosis and it diminishes the effectiveness of the mucociliary apparatus, that can be the thing that predisposes one of these carriers to now break with APP as it gets down the airway and into an alveolus. In the case of PRRS, if you have acute PRRS, PRRS kills the macrophages, and the macrophages are the first line of defense against bacterial invasion. So now you've killed another part of the protective mechanism. That may be the bomb that sets off the APP from a carrier to an outbreak.
You are listening to Meet the Expert, a new series of podcasts on swine disease management in practice presented by Boehringer Ingelheim. If you would like to know more about the subject we're discussing in this podcast, additional information is available offline. Detectable in any way at all? Is there any sort of protection one could suggest for that?
That's more complicated to answer than you might think. Yes and no. Yes, detectable from the standpoint that a majority of those carrier animals will seroconvert. So if you use serology, you can find them as being seropositive for the serotype that your virulent strain is. Okay, that's the good news. This is the bad news. The number of animals that carry those highly virulent strains is pretty low. And as a result, if you have a herd of 1,000 animals and only 2% of them are carriers,
You got a sample ahead of
there's only 20 animals that will be seropositive.
Yeah.
And you have to sample a tremendous number to find even one of those 20.
Yeah.
So the cost of doing that much serology is quite high.
Yeah.
Yes.
You wouldn't really contemplate it, and your chances of success are still not
Right.
great.
And the only time that you really contemplate things like that are as if you are buying seed stock from a herd you've never purchased from, and you want to make sure that herd doesn't have the APP strains.
Yeah.
Yes, that's when you go to that much trouble. And even then, it's going to have to be worth a lot to you to get that negative answer, because it's going to cost a lot to get the answer.
Yeah.
Typically, where that kind of money is spent is when people are paying large amounts of dollars for animals that are going to be put in bore studs, that the value of the animals in those bore studs is in the millions of dollars.
Yes. So protection lies in what you do on in terms of mycoplasma and other things in your herd management.
Yes.
To ensure yourself against these events which could make the bomb explode.
Absolutely.
That's what you suggest.
Yeah, we talk about, there's a book that doesn't have to do with veterinary medicine that was famous in the business world, and it talked about tipping points.
Yes.
Basically complicated scenarios, where there's not any one thing you can blame, but you just have a whole lot of small things that finally build up to the point that you get to a tipping point, and then you have a crisis.
Right.
APP is a perfect example of that. There's usually not a single thing that you do that causes you to have the outbreak that you have, and there's not a single thing that you can do to make the outbreak go away. It's a whole variety of small things that lead up to the outbreak, and then in order to have the outbreak go away, it's taking care of a lot of those small pieces until you get it below the threshold for the tipping point of the disease.
So if you hear coughing, it may not be APP, but it could be setting the scene for it.
It could be setting the seed, exactly. And then if you go out and find dead pigs with blood running out of their nose,
You know where you are.
at least you want to have that as being a differential for that being. And
Yes.
you'll find most swine producers and swine veterinarians, when they find good pigs that they didn't expect to die and they have fresh blood running out of their nose, that's the thing that they're most afraid that is happening. Yes.
Right. And what can they do for, is there intervention by the vet or the advice of the vet that would be helpful once you see those dead pigs?
The good news is Actinobacillus pleuropneumoniae among bacteria is pretty sensitive to antibiotics. There isn't a lot of resistance to it, so treatment with antibiotics is fairly effective. The issue, though, is that when animals start to get sick, they go off feed and their water consumption decreases. So in order to get therapeutic levels of antibiotics into those sick animals, it's sometimes difficult without actually having to inject animals by hand, treat them parenterally. And depending on numbers of animals you're dealing with, that it takes a lot of labor. But that is typically what happens. They may use a metaphylactic antibiotic on the population for a short time, but then you have to treat parenterally those animals that are sick to get an adequate level of antibiotic in them.
Yeah. Dr. Stevenson, thank you very much indeed for this look at the other agents which are in coughing, but we should say involved in respiratory disease complex, and the differences between them I take to be the tipping points, the dose dependency, the time, the transmission, and the visibility from the evidence that comes to the laboratory.
Absolutely. It's been a pleasure being here.
You have been listening to a Meet the Expert podcast presented by Boehringer Ingelheim. Please note that other podcasts in the series are becoming available. Stay tuned and thank you for listening.